Ratio test. Test for convergence and divergence. Series test. Is convergent or divergent? Ratio test. Summation of an. If we have given the factor, if in an we have given some factorial or powers of n, then we can apply the ratio test, and the ratio test is applied by limit n tends to infinity at the put n plus 1 on the n and upon may an, the absolute value of that, calculate that, and put limit n tends to infinity equals to L. That limit, if value of L is greater than 1, then the series converges. If value of L is less than 1, then the series diverges. If L equals to 1, if the value of the ratio is equals to 1, then test say nothing. Then we will have to use some other test, but not the root test. I will explain it later. If L equals to 1, we are just gonna do some examples of ratio test, that is summation of n equals to 2 to infinity ratio test. Limit n tends to infinity, taking the absolute of an plus 1 upon me an, and limit n tends to infinity. Now put n plus 1 on 3, we will get 3 n plus 1 upon n plus 1 upon an, 3n n log n. Here we can see that all the values are positive. Then we can say that 3n plus upon my 3n multiply by n plus 1 as we can see that it will become 3 and it will become 1 upon 1 plus 1 by n. But in this case, if we put n equals to infinity, if we put n tends to infinity, we will get the value of infinity over infinity. Then we will have to use the L hospital rule, which is if fx over gx limit x tends to infinity equals to infinity over infinity, then we will have to put the f dash x and g dash. We will have to take the derivative, and we have calculated the derivative, and we get the value ln x over ln x plus 1. We will get 1 by x multiplied by x plus 1 x plus 1. Then put, which if we put x tends to infinity, then we can write it as 1 by x upon 1. Put x tends to infinity, then we will get 1, and then I can say that it will be 1 by 1 plus n over 1 and limit n tends to infinity, the power is, there is nothing to 3, put n tends to infinity, we will get 1, then 3, 3l equals to 3. Then here we can see that 3 is greater than 1, then series diverges because this is a special case. Here we are taking the geometric series of 3n. In geometric series, if an plus 1 upon by an equals to rn plus 1 by r to power n, if value of r is less than 1 then converges, otherwise diverges. It is a special case where the geometric series applies. So guys, if you have doubt, then just comment below and I will go through it as soon as possible. And I will give another example where L equals to 1 and where tests say nothing. We will have to do some other tests, and I will do root test on my later videos. So guys, just subscribe and share my channel and hit like button.